All right, so what we're trying to accomplish here is to look at a coordinate plane, and we're going to be given a set of coordinates that creates some kind of a quadrilateral, some kind of four-sided shape. And our job is to try to classify it as precisely as we can. So we're going to take a look at it and first establish that it is a parallelogram, or maybe it's not a parallelogram. Okay? And then once we know that for sure, we're going to try to be a little bit more precise and say, is it a special type of parallelogram? Could we say, for example, that it is a rectangle, or a rhombus, or a square, or some other special parallelogram? Right? And so to do this, we have a couple of calculations that we're going to have to do on the coordinate plane. So the first one is we are going to calculate the length of the sides. Okay, and I'm going to show you a nice little shortcut that saves us having to calculate all of the lengths, but we're going to have to calculate the lengths of some sides. We're going to have to calculate all of the slopes of the sides, and then we're going to have to use that to draw a conclusion about what type of shape it is. So we have to do, essentially in each of these problems, 6 calculations. Okay, and I'm going to show you some variation about what you prefer. Okay, so here are the conclusions that you could come to after you do your calculations. If you find out that both pairs of opposite sides have the same length, then it's a rhombus. Okay, so first we're going to figure out that it's a parallelogram, which, remember, if something's a parallelogram, that means that when we do this, calculate the slopes, opposite sides have the same slope. Then we can say definitely parallelogram, right? Then we're going to have to look at the lengths of the sides. If all of the sides have the same length, okay, using a distance formula calculation, we're going to be able to say it's a rhombus. When we look at the slopes, if we find out that 2 consecutive sides, which means 2 sides that connect to each other, if their slopes are both reciprocals and opposites, that means that the lines are perpendicular, and we can say that it's a rectangle. Okay? And then the nice thing about this, about parallelograms, is we don't have to do anything extra for a square, because the definition of a square is something that is just both a rhombus and a rectangle at the same time. Right? So let's jump in and we'll see this happening, but we're going to just do these calculations and then do a nice little comparison here. Okay? So I'm getting a little cut off, but what this is basically saying is we have this quadrilateral with vertices math, right? And we're going to draw the quadrilateral and then figure out what type of parallelogram it is. So what I've done here, just to save us some time, typically we'd have to draw ourselves a coordinate plane and put these points on, right? 1, 5 would be kind of like somewhere up here. Okay, 5, 1 is going to be over here, and 0, negative 4 is going to be somewhere down here. So if you notice what happens is the order that I wrote the letters, just to save us a little bit of time in this video, it connects in the order that we've written it. So M connects to A is connected to T is connecting to H. Right? So instead of drawing the graphs of all of these, we're going to be a little bit, take a little bit of a shortcut, and instead I'm just going to draw just a generic quadrilateral. Okay? And I'm going to say this is MATH. But when I connect it, I'm going to make sure I connect M to A to T, T to H. Okay? So if I'm looking at this, I need to first take a look at this and say, is this a parallelogram? And so the way we're going to do that is to use the definition of parallelogram, which says that both pairs of opposite sides should be parallel to each other. So I need to show that MA and HT are parallel lines. And on a coordinate plane, we do that by showing that they have the same slope. So I'm going to use my slope formula on MA. Okay, and remember, slope is subtract my y's. So that would be, in this case, 5 minus 0. And on the bottom, I'm going to subtract my x's, being careful that I do 1 minus negative 4. Right? And I need to do the same thing with TH. Right? So TH is my bottom line, and I need to make sure this has the same slope. So I'm going to say negative 4 minus 1. Okay, and on the bottom, 0 minus 5. Okay, so let's find out if these are, in fact, the same slope. So 5 minus 0 is 5, and 1 minus negative 4 is also 5, so it looks like I'm getting a slope of 1. Okay, on the bottom, it looks like negative 5 on the top, and negative 5 on the bottom, which, if you remember, negative 5 over negative 5 comes out to be a positive number. It's also positive 1. So I can say, yes, definitely, the top and the bottom are parallel because they have the same slope. Right? We need to do the same thing now with the left-hand side and the right-hand side. We need to make sure that they have the same slope. So I'm going to do a calculation on MH. And I'm going to say, in this case, MH would be negative 4 minus 0, okay, over 0 minus negative 4. Hey, again, be careful with your subtracting negatives. This looks like negative 4 over 4. Which is negative 1. And then I need to compare that to AT, which is the right-hand side that it better have the same slope as, or we don't have a parallelogram. So it looks like this one will be 1 minus 5 over 5 minus 1, which again, negative 4 over 4, which is negative 1. Right? So I've done my 4 calculations, and I can start to draw some conclusions. So the first conclusion I'm going to say, right, which I have that hiding down here, is this a parallelogram? I'm going to look at my slopes and say my top and my bottom have the same slope, so they are parallel. The left-hand side and the right-hand side have the same slopes, they are parallel. I'm going to say yes, it is a parallelogram, and it is a parallelogram because I can say both pairs of opposite sides are parallel. Okay. So yes, definitely it is a parallelogram. Hey, I'm claiming that now we can actually also answer the second question, is this a rectangle? Because remember, what needs to be true in a rectangle is that all of these sides would have to be right angles, okay, if this is going to be a rectangle. So on a coordinate plane, the way that we figure out that two lines are perpendicular is to also look at their slopes, which I have them already. So here's what needs to be true. I'm going to check MH and HT. So MH has a negative 1 slope. HT, okay, has a 1 slope. I need to be able to compare these slopes and say that they are both opposite, which means their signs are different, and that's true. This is negative and this is positive. And they must also be reciprocals of each other. And in this case, it's a little bit tricky. In this case, if I were to take 1 over 1 and take its reciprocal, which means flip it over, I also happen to get 1 over 1. In most cases when we're talking about reciprocals, I want it to look like this. 2/3 becomes 3 over 2. But if I have the same number on the top and the bottom and I flip it, I'm going to get the same thing again. So in this case, I can say what's happening is, yes, these are definitely opposite signs, and they are also definitely reciprocals of each other. So I can say that MH and HT are perpendicular. And if I compare all of the rest of the sides with ones that they're connected to, that's happening everywhere. MH and MA. Well, MA is 1. MH is negative 1. They are opposite reciprocals. So that's true of all of my sides. So I'm going to come down here and say, you know what? This is a rectangle. And it's a rectangle because all angles are right angles. Okay? And again, I'm proving this, okay, because I'm showing you that on the coordinate plane that all of the slopes of consecutive sides are opposite reciprocals. Right? So we now know that this is a parallelogram. We know that because it's a parallelogram, it is also a rectangle. Okay? And now we just need to establish, is this or is this not a rhombus? Okay? So we have a couple ways we could do this. So the first way is to actually measure the sides. Okay? And I claimed when we started this that we didn't actually have to measure all 4 sides. We only have to actually measure 2 of them. And here's why. Because we know this is a parallelogram, one of the properties of parallelograms is that opposite sides are always equal. So without ever measuring MA and HT, I know that they are the same length. Without measuring MH and AT, I know that they are the same length. Right? But what I don't know for sure is that MA and AT, that those ones are the same length. Or I don't know that MH and HT, that those two are the same length. So I really just need to compare 2 consecutive sides and establish that they are the same, and then I know that actually everything in the parallelogram would have the same side length. So we're going to do MA, okay, that's the one on the top, and we have to use the distance formula, which the distance formula is a big radical, and we're going to subtract the x values. So I'm going to come up here so we can see M to A. I'm going to say 1 minus negative 4, okay, and I'll show you the plug-in, squared plus 5 minus 0 squared. Okay, so I'm going to simplify this. This looks like 5 squared, which is 25. Okay, this looks like 5 squared, which is also 25. So it looks like I have the square root of 50. And I am not going to even bother simplifying the square root of 50. All I care is that when I check one of the sides that MA is connected to, which I'm going to use AT, when I check AT, it better be a square root of 50 as well. If it's not, we're done. It's not a rhombus. But if they match, then we're actually going to say, yeah, this is a rhombus. Right? So let's check AT. So AT, I'm going to do the same distance formula, find out how long it is. So I'm going to go from A to T, 1 minus 5 squared, okay, and 5 minus 1 squared, plus 5 minus 1 squared. 5 minus 1. Let me get my eraser. Okay, so 5 minus 1 squared, which is also 16. Okay, so this looks like 1 minus 4 squared, I'm sorry, 1 minus 5 is negative 4. Negative 4 squared, 16 plus 16. That looks like the square root of 32. Okay, so I'm going to look at these and say, MA is the square root of 50, AT is the square root of 32. That means that those sides are not equal to each other. And so I'm going to come down here and say, this is not a rhombus. And I know it's not a rhombus because all sides are not equal, or are not congruent. Okay? And I can also eliminate square as a possibility because remember, the definition of a square is a quadrilateral, or a parallelogram more specifically, a parallelogram that is both a rhombus and a rectangle. Right? A square has all equal sides as well. So because I'm showing you that the sides are not equal, I'm going to say, because it's not a rhombus. If it's not a rhombus, if it's not a rhombus, then it's definitely not a square, right? So once we eliminate either rectangle or rhombus, we can also eliminate square as an option. So again, we went through and we said, for slope calculations, yes, it's a parallelogram. We used the same slope calculations to say whether it was or was not a rectangle by looking at whether consecutive sides are opposite reciprocal slopes. And then I did a distance formula calculation to see if consecutive sides were equal to each other. And these 6 calculations are enough on a coordinate plane to show that we have what type of parallelogram we have.